Hello 3D printing friends. Today on the BV 3D channel we'll get a look at a new 3D printer from BIQU, the Hurakan. Stick around and we'll get into it right after this. I'm Brian and you are watching BV 3D. This episode of the BV 3D channel is brought to you in part by these awesome channel members. Becoming a member is a great way to support the channel and has a few perks besides just getting your name in lights here. Click the join button to find out more. Hi, welcome back. Hey, if you're new here and you're wanting to learn about 3D printing, 3D modeling, and other 3D printing related stuff, start now by subscribing and clicking the bell so you don't miss anything. Okay, so today we're taking a look at the BIQU Hurakan. Not hurricane, Hurakan. So what is the Hurakan? It's a more or less standard 3D printer in the i3 style with a Cartesian motion system. Now that's a fancy way of saying it's got separate motors for the X, Y, and Z axes. The i3 style is commonly referred to as a Bed-Slinger because it moves the bed back and forth. Other styles of printers, such as those in cube-type frames, typically raise and lower the bed, while still others, such as Delta printers, have a bed that doesn't move at all. BIQU says the design was inspired by Italian supercars, and based on the name, the inspiration may have been the Lamborghini Huracan. Although the front-end design on the printer does look nice, I don't see the resemblance between it and the Lamborghini. Honestly, the front of the printer looks more like a rack-mount network switch or file server. So let's go over the specs real quick. It has a frame made of V-slot aluminum extrusions with V-slot wheels for the X, Y, and Z axes. It has a build volume of 220 millimeters on the X-axis, 220 millimeters on the Y-axis, and 270 millimeters on the Z-axis. It has a Bowden drive extrusion system with a filament runout sensor so it can let you know when to run out and get more. It uses two filament drive gears to get a good grip on the filament to push it down the tube to the 0.4 millimeter nozzle. It has switch selectable bed heating, so you can choose whether to heat the whole bed for larger models or just the center portion if you're printing a smaller model. The nozzle can reach 260 degrees Celsius and the bed can reach 100 degrees Celsius. The bed also has a textured PEI print surface on a magnetic spring steel sheet. The power supply is integrated into the base of the printer. It has a single Z-axis stepper motor and lead screw. It has a 128 by 64 pixel monochrome LCD with a control knob. It has a BIQU touch probe for getting a mesh of the bed, and it's super small. The probe is integrated into the toolhead design, and it doesn't look out of place. It has an LED on the toolhead to light up the area around the nozzle so you can see what's happening while it's printing. And it has really good nozzle visibility as well. The parts cooling fans are located on either side of the toolhead, so there's not a fan duct in the way when you want to see what the nozzle's doing. It also has an LED backlight for the screen, and both the nozzle LED and the screen backlight LEDs are RGB, so you can set them to whatever color you like. There are presets for red, green, and blue, and you can also set them to custom values, so if you have a favorite shade of purple, you can make that happen. It has belt tensioners on the X and Y axes. It's running TMC 2209 silent stepper motor drivers on all axes, so the motion system is quiet. And those are mounted on a 32-bit mainboard that they call the Manta. It has Wi-Fi on board, and it also has ports. Lots of ports. It has a micro SD card slot, a full-size SD card slot, dual USB ports, an Ethernet port, and an SPI interface. Why does it have so many ports? Because it also has a single-board computer inside running Debian Linux. Now you might be wondering why it has a separate single-board computer inside running Debian Linux. And the reason is that this printer is, as far as I know, the first mass-produced i3 style printer that comes from the factory with Klipper firmware installed. I've talked about Klipper a few times in the past, most recently in the review of the FLSun V400 Delta printer. But for those who may be hearing about it for the first time, Klipper is an interesting beast. It's a 3D printer firmware that uses a small computer to perform the computationally heavy part of 3D printing. That is, interpreting your slicer's G-code commands to plan the timing and movements needed to print a model. The computer sends those movement instructions to the main board in the printer, which then carries out those instructions. So the software running on the main board doesn't have to spend time doing a bunch of math homework, it just has to control the stepper motors in the screen and keep the onboard computer informed about certain things. Stuff like the bed and hot end temperatures, and whether the knob on the front of the screen has been turned or pressed. Now this differs from a 3D printer running Marlin firmware, where the main board on the printer does everything. Now that said, I think for most consumer-level printers, the processing chips on modern 32-bit mainboards are up to the task of doing everything that Marlin asks of them. On the Hurakan, there are several components comprising the Klipper installation, some of which provide a really nice web interface for controlling the printer when it's connected to your network. For ease of reference, I'll be referring to the entire assembly of software components as Klipper. For those who want to know what's under the hood, I see Klipper, Klipper Screen, Crow's Nest, Moonraker, and Mainsail listed in the Update Manager in the Hurakan's web interface. Okay, let's talk about the initial setup of the Hurakan. Assembly is fairly straightforward. Although not quite as assembled as some i3 style printers, this one's not bad. The X-axis arm isn't mounted on the gantry from the factory, but the Z-axis stepper motor is. So you'll have to remove the motor, install the X-axis arm, and then reinstall the motor. Not a huge deal, and they probably did this to keep the size of the box down somewhat. Then the gantry assembly gets bolted to the base with 4 bolts, and then you connect all the wires and adjust the V-slot wheels to get rid of any wobble on the X, Y, or Z axes. Check that the power supply's voltage switch is set to what your wall outlets provide, and then turn the printer on. Now the manual that comes with the Hurakan is really more of a pamphlet with some basic assembly and getting started instructions. On the last panel of the instructions, there's a QR code and a link. I recommend you go to that URL where you can download a more full-featured PDF version of the manual. Both the included instructions and the PDF version walk you through the assembly and setup process, including manually tramming the bed and then getting a mesh of the bed with the probe so the printer can compensate for any high or low spots on it. They also cover the process of getting the printer connected to your Wi-Fi network, although I think those instructions could be a little more clear. Of note, you don't have to connect the printer to your network. It's certainly usable without the web interface, but I think that by not having the printer accessible on your network, you miss out on a lot of the benefits of Klipper. One of the things you'd miss out on is input shaping. This is a feature of Klipper that uses an accelerometer to measure the vibration of the X and Y axes when moving at different speeds to cut down on ringing artifacts on the surface of prints. And BIQU includes an accelerometer module specifically for this purpose. But the only way to tune the input shaper is by using the console in the Klipper web interface. The instructions for this were reasonably clear, covering how to attach the accelerometer to the toolhead and to the bed, and which commands to type in the console. While the process is running, the printer moves the toolhead left and right at various frequencies, noting the response from the accelerometer, and then it performs an analysis and writes a value into the configuration file so that it can try to reduce or eliminate ringing on the surface of a print. And it also does this for the bed. Does input shaping actually work? Well, I'll show you some before and after print samples in just a bit when I go over the things that I printed. So what about actually using the printer? Well, first, if you're using it without connecting it to your network, you have a couple of options for getting G-code files onto the printer for printing. The first way is to copy G-code files to the G-code folder on the printer's microSD card. But this card is also the onboard computer's boot drive, and that card should not be removed when the printer's on. If you forget that little tidbit and remove the card as you would on a Marlin-based printer, that's the same as ripping the hard drive out of your computer. It crashes instantly, and you risk corrupting the operating system and rendering the onboard computer unbootable, and therefore making the printer unusable. So if you want to go this route, always shut the printer down using the shutdown command on the screen, and then turn off the power before removing the card. An easier way is to put G-code files on a USB flash drive and then plug that into one of the USB ports on the back of the printer. You can unplug and plug the flash drive while the printer's on without having to shut it down, treating it just like you would the microSD card on a Marlin-based printer. Oh, and that full-sized SD card on the front, Klipper doesn't see it, so you can't use it. It's a little weird to have what amounts to the onboard computer's brains parked on a card right in the front of the printer, where it can be yanked out and cause issues, and it's a little weird that the card slot right next to it isn't actually used for anything. And it's also a little weird to have the safest non-networked way to get files onto the printer, the USB ports, around the back of the printer where it's not super convenient to reach. But having the OS card accessible and removable is a good thing because you can easily remove it to back it up, or to restore a backup, or to re-image the card with the factory image if it gets corrupted. Maybe a second version of the Hurakan will have the two card slots on the back of the printer and one or both of the USB ports on the front. Now, realistically, I would suspect that most people will want to put the printer on their network either via Wi-Fi or Ethernet, and doing so makes getting files to the printer a drag-and-drop affair. Slice a model in your slicer, save the G-code file to your desktop, and drag it onto a web browser that's displaying Klipper's web interface. A few seconds later, the file's been uploaded to the printer, and then you can select it from the G-code Files tab and start printing it. Now, you can also select it from the printer screen to start printing. If you're using Ultimaker Cura as your slicer, you can install the Moonraker connection plugin and upload the G-code file to the printer directly from Cura right after slicing, and even have it automatically start printing. Now, speaking of Cura, BIQU's instructions for configuring Cura are to add a BIQU B1 printer and set its build volume to 220 by 220 by 270 millimeters. I did this, but I also noticed that in the printing profiles under Travel, the retraction value was set to 7 millimeters, which seemed a bit much. I reduced that to 4.5 millimeters, and I'm getting really good results. This is probably a good time to show the models I printed with the Hurakan. Here, take a look at these. This is the first print from the Hurakan. It's a Benchy, and it looks like BIQU scaled it up to 150% for some reason. Because it's larger, it takes longer than a Benchy usually takes, clocking in at just under 2.5 hours. But it did come out pretty good. I don't see any issues with the print. The overhang at the bottom of the bow is perfect, the bridging on the top of the front window is close to perfect, and the arches on the doorways look good. About the only real issue I see is this one line around the wheelhouse that seems to align with the undersides of those arches. This retraction/stringing test came out perfectly. This is with the 4.5 millimeters of retraction, as I mentioned earlier. There isn't any stringing, and the two columns look really good. This 20 millimeter CHEP calibration cube came out pretty good too. The dimensions of it are pretty spot on. There are some layers that show artifacts that align with features on the CHEP logo. Now, it may be that this matte gray filament highlights those issues. I can see them more than I can really feel them. Next, here's MacGyver's Cali-Dragon, printed at normal speed and normal size in some Filamentum Pearl Green PLA. Sadly, this color isn't in production any longer, but it's a nice dark green. There are a couple of little wisps of stringing between the antler things, but that's not a big deal at all. This came out super clean and detailed. I also wanted to see what would happen if I printed this exact same file but cranked the speed up to 200%. However, because it's such a small model, running it at 200% speed really didn't make a big difference in print time. But since it cut the minimum layer time in half, it did make a difference in print quality, with the antlers looking a bit rougher and with a bit more stringing. Then I printed Aria the Dragon, and she came out pretty good. She was a 2-hour 24-minute print, almost exactly the same amount of time as the 150% Benchy. As far as issues go, the back of her right foreleg is a little rough, but stringing is minimal. I also see a little bit of pitting as a result of a Z-seam showing up on the side of her tail. Then, to print something tall, I scaled Aria up to 200% size. At this scale, she's 260 millimeters tall, just shy of the full build height of 270 millimeters. This time I printed her with Protopasta's Nebula Night Glow fluorescent filament. Nebula has fast color gradients between purples and blues and lots of glitter. There are a few little strings here and there, but nothing major, and at this scale, she's pretty impressive. Next up, the input shaping test model. I printed 2 of these, one before setting up input shaping and one after. The before print is on the top and the after print is on the bottom. There wasn't a huge amount of ringing to begin with on the big X and Y panels on the before print, but it is there. And it's pretty much gone on those panels on the after print. And there's a reduction in ringing on the outer panels as well. So from what I can see, input shaping does what it sets out to do. The Hurakan isn't a perfect storm, however. Occasionally it exhibited some weird behavior. Once, Klipper shut down in the middle of a print. The screen on the printer either froze or went blank, I don't remember which. And checking the web interface showed this: Clippy state shut down. MCU shut down, timer too close. and a list of possible causes, some of which could be that the onboard computer was busy or got too hot or had some other issue. Now this only happened once when printing a Benchy, but it was a little disappointing. Here's another weird thing. When turning off the power switch, all the lights on the printer flicker several times before it finally dies. And the final weird thing is you can set the Z offset from the screen on the printer, but this value isn't retained between reboots. It's an on-the-fly temporary adjustment only. Before I figured that out, I would adjust the Z offset at the beginning of a print to bring the nozzle a little closer to the bed to get the filament to stick, and think it was permanently set. And the next time I turned it on to print, my Z offset was gone, and then, because the nozzle wasn't as close to the bed as it needed to be, the model would pop loose during the print and yay, failure! One time I started the Benchy and watched the first couple of layers and then walked away. It popped loose a few layers after that, so instead of a 3D Benchy, I got a 3D blob. This specific printer in my possession has a couple of issues that are being addressed by BIQU. One is that the Z-axis lead screw is bent. Now this likely happened during shipping. And that said, it hasn't caused any problems that I've been able to see. The brass nut that connects the Z lead screw to the X-axis arm is mounted in a sort of floating manner, so it has plenty of wiggle room in the X and Y axes to cope with the bend in the lead screw. The other issue has to do with the heated bed. Back near the beginning of the video, I mentioned that the bed has a selector switch, so you can choose whether to only heat the center of the bed or heat the whole thing. So you can be a bit more energy efficient on smaller prints. But on the printer that I got for review, the center zone on the bed doesn't heat at all, no matter what the switch is set to. The outer zone is apparently powerful enough to heat both itself and the center zone, even though the center zone doesn't have power. I haven't seen any similar complaints about the Hurakan, and 3D Print Beginner on Twitter posted this image from a thermal camera clearly showing that center-only bed heating was working. At any rate, BIQU is sending me a new Z-axis lead screw and a new bed, so I'll be able to resolve these issues. Okay, so with weirdness and failed parts out of the way, I feel like I need to mention that Klipper requires special care and feeding more than you'd have to do with a printer running Marlin. Now some of this I've already mentioned in passing, but I want it all in one place in the video. While you can copy G-code files to the G-code folder on the OS card, you have to shut down the printer from the screen or the web interface, which shuts down the onboard computer, before removing the card, or you risk corrupting the operating system. When you turn the printer on, you have to wait for the computer to boot and then load Klipper, and this can take up to a minute. And you have to shut down the printer before powering it off. If you just cut power without shutting down properly, the onboard computer's operating system could become corrupted. Also, because Klipper is running on a computer inside the printer, good computing practices suggest that you should keep the operating system and all of Klipper's software components updated. The reality of the situation, though, is that apart from the operating system, updating the Klipper components or trying to get them to show a green up-to-date label instead of invalid, dirty, update, or unknown is likely to result in breaking some of the functionality that BIQU has configured in Klipper. I know this from experience. I spent some time running upgrades on the printer a few days after I got it, and I was supremely proud of myself for having gotten all the software components to show that green up-to-date label. And then I noticed that when using the printer's screen to select a file to print, it wasn't behaving the same way as it was when I first got it. And I noticed that the menu to control the hot end and screen backlight LEDs was just plain gone. It turns out that in the process of getting all those updates to actually update, I broke it. Like here, where Klipper shows invalid and Klipper screen shows dirty, there's a soft recovery and a hard recovery option. The soft recovery options failed, so I ran the hard recovery options. They worked and got me that green up-to-date label that I wanted to see. But the way they worked was by reverting to known good base configurations, and these didn't have the extra menu configs that BIQU had added. Now I reached out to BIQU, and it's something they know about. I asked them if they could send me the disk image for the operating system so I could return the printer to factory settings, and they provided a link for it. BIQU should make that disk image available on their support page so that you can download it and keep it handy in the event you need to reflash the image on the OS card. I used the free Balena Etcher application to reflash the card, and now, with the exception of keeping the operating system on the printer's computer up to date, I'm just leaving the other items in Update Manager alone. I mentioned Klipper's configuration a minute ago, and I think making changes to it is easier than in Marlin. rather than Marlin's process in which the firmware is edited, then compiled, and then flashed to the printer via the SD card or USB. With Klipper, its configuration information is stored in text files. Edit the file, save, and reboot the printer. As a bonus, this can be done from Klipper's web interface. Okay, now I think that about covers the care and feeding of Klipper. This video is running long, so I'm gonna start wrapping things up. Here's what I like about the Hurakan. It has a nice looking design. I don't think it looks like a Lamborghini, but I do like the way it looks. I like that it includes an accelerometer module to tune the input shaping feature, and it includes that single board computer running Debian, Linux, and Klipper. The bed probe is super small and seems to work really well. Klipper stores the bed mesh information and uses it for every print, so you don't have to spend time getting a new mesh at the start of every single print job. I like the textured PEI on the spring steel sheet, and I like that it's double-sided. It makes removing a print super easy. And I like the web interface they've included with Klipper. I also like what they've done with the fans. They only run when they need to. This thing is dead quiet when it's idle. Right now it's on and it's idle and I can't hear it. Okay, now here are the things I don't like. The Hurakan's only heat the middle of the bed feature. It's supposed to be a power saving feature, but it never worked for me. If I have the switch in the off position, which is the only heat the center of the bed position, the bed won't heat at all, and Klipper shuts down with a thermal error. Like I said earlier, this seems to be a problem with this one specific printer, and BIQU is sending a replacement bed, but this should have been caught during testing before it was shipped. Also, because the Hurakan has an onboard computer, in addition to all the usual maintenance stuff you have to manage with a 3D printer, you also get to manage a computer, keeping its operating system updated and taking care to shut it down properly. So if you're used to a 3D printer being more of an appliance, having to deal with the computer aspect of it is something you need to be aware of. I guess maybe that's more of an FYI than a dislike. The onboard computer's operating system is stored on the microSD card sticking out of the front of the printer. Removing the card while the printer is running is a great way to corrupt the onboard computer's OS. Also, of course, the printer will halt immediately because the computer that's controlling it has just had its brain removed. I think it would have been better to have the micro SD and full-size SD card slots at the rear of the printer and the USB ports on the front. So that's the BIQU Hurakan. Despite that list of dislikes, it's a good machine. It's just different than what I'm used to with Marlin. It's had no problem printing files I've sliced with either Prusa Slicer or with Cura, and it's done a good job with them. It's running Klipper, but it isn't trying to break speed records. It is trying to be the first i3-style Bed-Slinger that comes from the factory with Klipper installed. Plus, BIQU has various and sundry upgrades you can add on to it. And that's kind of the thing with this printer. I think the target audience is not the people who want that take it out of the box and start printing experience. It's more for people who like to tinker and want to kind of ease into Klipper, but the idea of bringing Klipper up from scratch is overwhelming. Sometimes I straddle that line of wanting to just print and wanting to tinker, and so I find the Hurakan appealing because it's mixing the familiar i3 design with Klipper. I just have to remember to use the shutdown command before I turn it off. Well, 3D printing friends, that's about all the time we have for this episode. And now that we're at the end, let's go print something cool. Hey, real quick before you go, I wanted to say thanks for being one of the super awesome people who sticks around all the way to the end, and thanks for all the likes, comments, and shares. And an especially big thanks to those who directly support what I do. You're all wonderful for doing that, and I really appreciate it. If you liked this episode, a thumbs up would be great, and if you'd like to help support the channel, check the description for ways you can do exactly that. And hey, if you haven't already subscribed, please do. It's absolutely free, and it's an excellent way to help keep me making these videos for you. Well, that's it for this one. Thanks again, and I'll see you next time here on the BV3D channel.